with the basic concept of sensor and transducer. Okay, so I have discussed. Okay, so I have discussed some of the portions in my last class. Basically, in my last class, I just started with the concept of sensor and transducer. What is the importance of the sensor and transducer? I just give some example. Okay, so as per the example, you can see that. You can see that I'm telling means there is some hot bowel in your kitchen, so you just try to touch. Okay, you just answer suddenly you just touch your fingertip to the bowel, hot bowel. Then what happened? Then your skin having some of the temperature sensor. Okay, that receive the signal and it is send it to the sensory neuron through your brain. So brain having some processing unit and it can process that data and it can suggest it that how much you can tolerate, how much you can able to tolerate. Then if it is beyond the able to range of that application, range of tolerance, then what happened, then it will give instruction to the actuators. Means what is your actuators? Body actuators means your muscles. Okay, please remove that hand, but who will take that signal from your brain to your actuators? So normally motor neuron is using motor neurons are taking this taking the instruction from brain to your actuators. Okay, and actuator do the work done. Okay, so that means removal of your hand from your hot bowel. Okay, that's the concept. So you can see that what is the importance of the sensor and transducer in a circuit. Okay, so both sensor and transducer both are using as a sensory part. Okay, as they are using the receptor. Okay, they are using the receptor of the signal. Okay, so that's why you are, as per the applications of their applications of the or as per the purpose of that sensor and transducer, you can say you can categorize them into different segments, like which one is sensor, which one is transducer. You can understand. So sensor means all the parameters. Okay, so all the parameters are converting in the form of electrical energy. Means physical parameters are converting in the form of electrical energy. But in case of sensor, it can convert any of the physical quantity. It can convert in electrical energy, sometimes mechanical energy, like that. Okay, there is no any fixed here fixed instructions. Okay, so as per the requirement, you can say like that, it can convert their range. Okay, so what are the most important classifications? So here you can see that you can understand the classifications of the transducer is your. Right now we have discussed about the transducer. Okay, so primary and secondary transducer. Okay, primary, secondary transducer, active and passive transducer, analog and digital transducer, and transducer and inverse transducer. Okay, so what is the primary and secondary transducer? That some of the transducers are able to measure that direct value. Okay, direct physical quantities, like your heat sensor. Okay, heat concept, your the sun sensors are there inside of your boiler. Okay, or the furnace. Okay, RTD, you can say like that, using like a transducer, and it can directly provide you the signal. Okay, like your electrical signal. Okay, that you can say it's a primary transducer. But in case of secondary transducer, means that direct it cannot apply, it cannot fetch, or it cannot take the data. Okay, sometimes what happens, the range of physical quantity is too high, you can say like that. Okay, so directly they are not able to take that value, so it can, due to the protection issues or due to the, otherwise what happens, if you directly give the transducer to the actual positions of your physical quantities or physical parameters, then it may cause for damaging of your transducer. Okay, that's why you have to put the transducer with certain distance. Okay, certain distance means another stages. You can introduce your transducer after certain stages. Okay, so that's why you can say like that, it is secondary transducer. Okay, so it can convert the signal, secondary signal, to your electrical signal. it is not converting from your physical quantity to second a quantity. It look like that way. So if huge heat is there, so some of the portion, so you can install your transducer after certain distance like that way. Okay, so it can be calculated. So due to the changing of the distance, how much value of temperature or how much value of heat is decaying. Okay, so then it is this, then your transducer is capable to take that data, capable to take that values. Okay, so how much values are there. Okay, that is only capabilities of your transducers. Okay, so that's why you can say like that it is secondary one. Sometimes active and passive transducer. Active and passive means it look like an active circuit and passive circuit. Some of the transducers are capable enough to directly take that results in the form of they will take the sense the physical system and convert that signal to the electrical signal. Okay, but some of the transducer, so there is no source requirement of additional source of EMF. Okay, additional EMF source, that is called the passive transducer. In active transducer, you should require another additional EMF source. That is your active transducer. Analog and digital transducer. So you can say that some transducer output is in the form of continuous signal. So you can say like that it is an analog transducer. And digital transducer means sampled output you will getting or you are receiving from the transducer end. So you can say like that it's a digital transducers. Okay, so continuous value we are not able to get over here. Okay, so that's the basic concept for the analog and digital transducers. Okay, so transducer and inverse transducer means transducers converting the physical signal to the electrical signal, and inverse transducer, the reverse thing will be there, electrical signal to the physical signal. Okay, so that's why the concept of analog to the transducer and the inverse transducers. An inverse transducer is a device which that convert the electrical quantity into a non-electrical quantity. So okay, so you can understand that transducer means converting the a non-electrical quantity of the physical parameter to electrical parameter, and inverse transducer means the reverse thing, that a non-electrical component to electrical component. Okay. So active and passive transducer, again it may be, you can see like that it may be categorized into few concepts. So active transducer, that is photovoltaic. Okay, so means photovoltaic means your transducer is affected from your photons, means solar energy. So that if that photovoltaic means light sensitive transducer, if that light is coming to the transducer end, so you will get some electrical output. So it is your photovoltaic transducer. Then thermoelectric means temperature related. Okay, so thermoelectric temperature, so is there any thermal effect is there, so you will get some electrical signal. So it's on the active transducer. Then piezoelectric transducer means, piezoelectric means pressure. Okay, so if you give some pressures, okay, so then you will get that output. Okay, so piezoelectric output, so that you can understand or that you can fetch that value. Okay, then electromagnetics means it's your LEM sensor, means magnetic field respective, means some of the transducer are telling like that I am telling you last class, the LV25P, then LV15, then LV25P is an example of electromagnetic transducer. Means due to the magnetic field, the change of the magnetic field may cause for the electrical source of generation. Means you can say like the tacho generators, all are that electromagnetic transducers. Then piezoelectric means pressures. Okay, if the pressure is there, the piezoelectric crystals normally there. So if you apply the pressure across the piezoelectric crystals, then some of the electrical input, okay, output is developed. Okay, potential difference you can observe across the transducers. Okay, across the filter, that is your piezoelectric transducer. Okay, then passive transducers are there, that variable resistance, all the cases variable resistance, optoelectronics, variable reactance, all the cases you have to give additional sources, EMF sources. These all are the example of a passive transducer. So I think you are able to understand what is active transducer, what is passive transducer. In variable resistance means photoconductance, strain gauge, okay, thermistor, all are the variable resistance. Then this example of a variable resistance transducers, and all are the passive transducers. Then optoelectronics means photo emittive, okay, so if photo junctions, that means photoemittive diode, photojunction diode. I think all of you heard about it. Then variable reactance means inductive, then capacitive. Okay, so very transducer means your mobile smartphone. Initially, it was capacitive. First, it was resistive. Okay, when means 10 years back. Okay, 2010, 2011. So they are at that time Sony first taking the smartphone in India. Okay, that time that. Touchscreen was basically that resistive nature. Okay, so like your variable resistance type nature, so it was quite slow. The touchscreen was quite slow. After that, generation has changed. Right now you can see the touchscreen or smartphone is everywhere. Okay, so you can say like that. Right now that capacitive type of skins, okay, sensor they are using. Okay, inductive and capacitive. So in inductive, you know about the proximity sensor. So in any of the shopping mall, if you try to enter, so you can see there is a sliding door. Okay, that is your proximity sensor. Okay, so that is normally inductive type of sensor. Okay, so infrared, you can say in one that infrared sensors. Okay, all are that inductive type of sensor. So in inductive type, so again that is variable reluctance, then variable permeability. Okay, then reluctance means you know that the magnetomotive force, the concept of the magnetomotive force and the expressions. Okay, so reluctance, permeability, linear LVDT. LVDT is very important. And finally eddy current based. Okay, so linear voltage differential transformers. Okay, that is your LVDT. Okay, so sorry, linear variable differential transformer. Okay, so that is your LVDT. Okay, so these all are the example of a inductive type transducer, active passive transducer. In active transducer means you have to require some additional EMF source, but in passive transducer no need of any additional source. Okay, so in capacitive type you can see that variable area, then variable separations means you know the expression of the capacitor epsilon L by D, na? So L 1 by epsilon L by T. So if you know the expressions of that one, so you can vary individual parameters. So the capacitive transducers also be its property also been changed. Okay, so variable permeability, all are related to the change of the capacitive nature of your capacitive transducer, capacitive type passive transducer. Okay, so after that you can see some of the definitions. Okay, so some of the definitions, you can see the definitions of that active and passive transducers. Okay, so from here you can understand, what is written like that. The So what is written like that in active and passive transducer? Okay, in active transducer, the output energy or the active transducer is supplied entirely or the almost entirely by its input signal. So in active transducer, what happened that input signal, so output energy of the active transducer is supplied entirely or the almost entirely by its input signal. So it is driven. Okay, and passive transducer, what is the definition of passive transducer? Have an auxiliary source of power. So passive transducer, you should require one auxiliary source of power. Active transducer, what happened? It having energy, inherent energy boost up capability. Those transducer having inherent boost up capability that is efficient or sufficient to drive the transducer. Okay, so in active transducer, no additional source of EMS is required, but in passive transducer, mandatorily one additional source of transducer is required. But in active transducer, from where it will get that additional power? It will get the additional power from the output of the that means it is written that means supply. Okay, so developed power, developed energy from the active transducer. It can sufficient enough to drive the transducer. Okay. Then passive transducer have an auxiliary source of power. This power source is necessary for the operation of passive transducer. Okay, I think you are able to understand. Thermocouple are the example of a active transducer, and microphone is an example of a passive transducer. So in microphone, you know that you have to give some additional supply. Okay, so in mic of the microphone, so it is an example of a passive transducer, but in thermocouple, automatically it will fetch that value. Okay, so it should not be in an it inherently it can develop its own EMF. So it is an example of a active transducer. Okay, so primary sensing transducer. Okay, what are the examples or the features of the primary sensing elements? Sometimes called the pickup sensor or the transducers. Okay, so it is known as the primary, that I am telling you, directly you put it to the electrical oven or the pressure gauge, oxygen sensor. So you can see different example of that passive primary sensing element, like your temperature sensor, pressure sensor, then oxygen sensor. All are the example of your primary sensing elements. So it detects the physical variables to be measured. Example, pressure, temperature, rate of flow, etc. To convert the signal into a more unusable form. So you can use that value, you can easily get that results from the physical variable to your system. Okay, in practice the physical variables is usually transformed into the mechanical or the electrical signal. If that physical variable directly output is the mechanical, so you can say like that it is an example of a sensor. Okay, if it is output is electrical, then you can say like a is a transducer. Okay, in analog and digital, so you can see some analog and digital example. So here you can see that heat is given. Okay, so some heat sensor thermocouple is there. Okay, it is a thermocouple, so heat is given. So due to the thermocouple, what happened, changing of that heat. Okay, junction temperature is changing. Okay, that may responsible for development of electrical energy. Okay, so that energy is coming here, and signal conditioning system means what is the purpose of the signal conditioning system, means it can amplify the signal. Okay, and you will get that analog output signal. Is an example of a analog transistor. Okay, so it is your thermocouple, it is analog sensors. Okay, so it is your output, it is your output and it is your time. Okay, and signal is there. So increasing that signal strength means may cause for your output. Okay, so it is your digital output signal. Digital output signal means what, how to get the digital value. So here you can see the slot, rotating shaft are there. In machine drives you can use you can use that coding decoding type of sensors. Means when the shaft is here, you can see light emitting diode is there and it is detected. Okay, so when light is passing, okay, so when light is passing through that path, okay, then detector will be turned on. Okay, so when light is not passing through that shaft, so detector will not enable, because it is photo effective detector. Okay, so it is your transmitter and light is coming over here and it is passing through that shaft and directly coming to the detector. Okay, so disc is rotating. Disc, if the disc is rotating, so your shaft will be rotate. Okay, disc slot is there, shaft will be rotate. So you will get the digital light sensor. Okay, when light is coming to the detector, so it will be turned on, you will get the signal. If light is not there, you will not get any signal. Finally we will get a PWM type signal. Okay, pulse width signal. Okay, so digital output signal, and digital counter and register is there, that may be responsible for that converting that signal to your digital display. Okay, so here your output is like that, your signal means discretized signal. Okay, when it will be on, you will get signal. When it will be off, you will get zero signal. So it is output to time configurations. Okay, discrete signal you are able to get here. Okay, so resistive transducer. Okay, resistive transducer means you can say like that, potentiometer is an example of a resistive transducer. Okay, so potentiometer having two fixed path. Okay, so this is your fixed time to fixed terminal. Okay, so fixed terminal is responsible for giving the input voltage, and in between one variable resistance path is there, and you can say like that one pot. Okay, potentiometer means pot. One changeover switch means slider is there. So potentiometer sometimes it you can say like that, if you can slider, so if you move the slider, you can say like that wiper contact. Okay, wiper contact. So if you move that one, if you able to move that contact, so what happened, their output voltage will be changed. Okay, here you can see multiple the resistance is there, then it is rotating like a spring. Okay, it is rotating like a spring, you will get that output voltage over here. Okay, and it is your heliport. Okay, it is called heliport pot, and input voltage is given here. So if you rotate that value, in slider rotations means that pointer will be changing from beginning to end. Okay, if it is changing from beginning to end, so output voltage also being changed. So it is your translatory. Okay, or the displacement, it is your rotational. Okay, different concept is there. Okay, so first one is your translatory, means it is linear. Okay, directly it's look like a rheostat. Okay, so only displacement, the displacement of the wiper, or you can say the slider, that portion is called the slider or the wiper, you can say like that, that output voltage will be changed. So now it is that variable resistance path, this variable resistance path, here it is linear. Now here the variable resistance path are in rotational name. Okay, now that wiper is changing, that positions may cause for changing of that output voltage. Okay, so it is called angular displacement. So it is called angular displacement. You are giving here that input voltage. So the input voltage you are giving here, and you can get that output voltage, and that output is rotational output. Okay. So here you are able to find out that heliport means both are there, so it is look like a spring. Okay, so that paths are connected in a spring, and one variable or wiper or slider is there that may move from here and there. Okay, from that zone, so that may cause that heliport configuration. So what is your output voltage? You will get that output voltage from your voltage divider rule. Okay, so Vg equal to R2 whole divided by R1 plus R2 into Vt. Okay, so that is your voltage divider rule. Okay. So then you can go for the resistive transducer, means your pot type transducer, fluid level sensor with a floater is there. So it's your Babcock is there, one Bock, it is, you can say like that, air balloon is there. So that may cause, if that fluid level is changing. Okay, so fluid level is changing, so that position also being changed. Okay, so from 0 to gradually it will be include. So if it is include, then what happened, that wiper or the slider of that variable register path, it is also being varying like that. It is varying. Okay, if it is varying, so output voltage will be different. Okay, and you are able to measure that value. If that output voltage is different, so you can say like that, how to movement of this value, you will get the different resistance, different voltage level. Okay, so in E, so we are giving that input voltage here. Okay, so we are giving some input voltage, so that distance is changing. Okay, so if the distance is changing, so output voltage also being changed. The voltage V across the wiper of a linear cord is proportional to the displacement D. So V equal to E, capital E whole into D by small d by capital D. Okay, so where D is the full scale displacement and E is the voltage across the plot. Okay, so I think you are able to understand. So if the displacement D is changing, okay, so that may change of that wiper positions or the slider position. If the slider position is changed, so output voltage also being changed. Okay, it is your capital D is capital total displacement. So the resistance pressure transducer, so it is your resistance pressure transducer. Okay, so that may cause for what, that here you can see some spring is there, it is a resistance pressure transducer diagram, the spring is there. Okay, so both the cases spring is there, that is resistance lead of external bridge circuit. Okay, and it is bellows are there, so pressure in inlet. So if that air is coming or the pressure is coming. Okay, so it sometimes air may cause for the pressure. So if that pressure is coming, that bellow is try to be coincide, means that length of the bellow is varying. Okay, if that length of the bellow is varying, then resistance contact also being changed. That resistance contact, that contacts also being changed. If that contact is changed, then what happened, that bellow movement coupled to the movable resistance contact. So movable resistance contact, here you can see it's a movable resistance contact. If the movable resistance contact is changed, so current flowing through the movable resistance contact will be different. Okay, as per the position changing of that movable resistance. Okay, so that may cause for different values of, coming to your output. Okay, so you can say like that, it is resistance pressure transducer. So changing of the pressures, okay, changing of the pressure, that may cause for changing of the resistance path, means the current flowing through the resistance path. Okay, so here another thing, the diaphragm is there. Okay, well, or you can say the diaphragm is there, another pressure so is coming over there, the spring is there. Okay, so spring is there, and you can see the contracts, you can see the contact is there, two contacts is there, resistance lead of the external circuit. If the spring is moving, so resistance path will be different. Okay, if the resistance path will be different, so output of the contact will be different. So you can say like the sensitive diaphragm moves resistance contact. Okay, so you can understand the concept. Then bellow and the diaphragms. Okay, so bellow and the diaphragms are there, all are the diaphragms. You can say like that, bellow, if the pressure is there, so bellows are moving. Okay, bellows are moving means sometimes it will be coincide, sometimes it will be expand. Okay, so if it is moving, or the vibrations. Okay, so moving, so due to that vibration, sometimes what happen, that may cause for the displacement, change of the displacement. And may change of the displacement means that if you fix up some coil, okay, and that coil is connected to the bellow, so due to the vibrations, that coil movement will be there in the permanent magnet. You can install some of the permanent magnet, so central limb of the permanent magnet. So that spring is due to the changing of the bellow positions, due to the vibration, so there is a movement of that spring, so that may cause for EMF generations. Okay, that may cause for EMF inductions over there. Okay, so I think you are able to understand the concept. So then we can go for that resistive transducer. So if you see that diagram, so in resistive transducer, what happened, so wiper are there, or the movable contacts. Okay, so here you can see the total resistance path. Okay, so you can see that conductors are coming, so conductors are coming, it is your wiper or the movable path. Okay, so movable path means here. Okay, so that position is connected over here, so 1 and 2. Okay, one is there, wiper configuration, and 2 is there, movable arm of the measurement, pressure measurement. Okay, so in pressure measurement, what happened, in bridge power supply is there. Okay, that is measurement of potential pressures. Okay, the potential pressure, due to the pressures, what happened, the displacement, the changing of the displacement, that contacts. Okay, that contacts will be moving from left side to right side. If that is moving, so that wiper, it will be moving. So due to the changing of the wiper, then what happened, due to the changing of the wiper, so output of that path will be different, output also been changed. If the output is changed, so definitely you can get that it may be the equivalent, it may be the equivalent pressures. Okay, that balancing also been changed. You can see that balance is there, R1, R2, R3, and that variable 1 2 means it's a variable, so 1 is connected to the wiper, 2 is connected to the fixed point. Okay, if you change that value, okay, so you can see then that like your bridge circuit. Okay, that movement of this meter you can observe. So when it will be in 0, so you can say like that it is balanced condition. So you can calculate that value, the resistance measuring bridge circuit. Okay, so you can able to calculate that amount of value, how much value of R4, so you can get that value of R4. Okay, by that way you can get that, you can say like the resistance may be used as a transducer. Okay, then here you can see that constructions of that another resistance transducer. Okay, and it is your model, circuit model. So all the cases in resistance transducer, it look like a pot. Okay, so two fixed coils, so A and B, two fixed coil is there, and wiper is connected in between that conducting strip and your fixed coil. Okay, so now if your shaft is moving, from linearly, means horizontal moving is there, so it can moving throughout the conducting strip and the fixed coil. Okay, so due to the moving, that output will be different, that weight is there, so balance weight is there, means due to, if that weight is increased, so what happened, that conducting strip also coming that side. Okay, if it is coming that side and shaft is there, so shaft also moving towards your as per the weight. Okay, so from there you can understand that weight is coming directly putting at the wiper or the shaft of the potentiometer. Okay, that means R1 and R2 both you can split like that. Okay, so from the R2, across the R2 you can find out the output voltage. So output voltage V0 equal to what? Vt into R2 by R1 plus R2. Okay, that direct formula is there. So as per the increasing of your weight, okay, so that slider is moving from upward to downward, from upward to downward, so it is moving down, and that may cause for voltage generation over here. So output voltage will be different. Okay, I think you are able to understand the concept. Okay, then you can say like that wiper control. So wiper control means giving the weight or giving or adding some of the additional pressures. Okay, so that wiper is changing. So if that wiper is changing, okay, so linearly changing means you can see that input, so that portion. So if it is changing means you can see the bellow. Okay, so bellow may be moving. Okay, that may be moving right side, maybe moving left side. So if it is moving right side or left side, so you can see as per the moving you will get some step input, step staircase type of output over here. Okay, so if you get the staircase type of output voltage with the displacement of the bellow of the wiper contacts, okay, so you'll get such type of output. So sometimes you can make it fixed value. Okay, so if it is moving, so sometimes you are not able to get that fixed one. So how to get that fixed one? So you can make it, you can average that value. Okay, for that position wise you can averaging it, so you will get that exact average value from there. Okay, after that we can go for the strain gauge. In strain gauge means you are giving some pressure. Okay, you are giving some pressure and you are able to find the output, electrical output. Okay, so that is wire strain gauge. Okay, in wire strain gauge what are the most important thing? Resistance wire. Okay, then again it will be classified into unbounded and bounded. Wire types are there. Okay, what types are there? Number one, grid, rosette, rosette, then torque and helical. Okay, so four what types are there. Okay, so foil strain gauge. Okay, in semiconductor strain gauge, all are the different types of the strain gauge. Okay, so you can go through it from any of the standard books. So as I am giving the very basic idea of the all the type of transducer, so I am I think you all of you up to date your knowledge. Okay, all of you are up to date to yourself to go through or to read the additional features or the most I'm telling you the very brief idea. Okay, I'm discussing the brief idea of the among all the contents of the syllabus. So my suggestions, all of you should go through or should read any of the standard books. Okay, so gather your knowledge. Basically instrumentations is your informative type subjects. Okay, so how much you can gather your knowledge, you will be benefited. Okay, at the time of placement, when you are will be in the industry, so at that time we can get that benefits. Okay, so I can cover that much option, that much I can cover how much portions of that course is. Okay, so you can follow any of the standard books to gather your knowledge. Okay, so only my slide is not enough. Okay, so the basic motivation to saying like that way, so my slide is not enough for giving all the, I can give you the brief idea about the subject course. Okay, but meticulously reading, okay, or meticulous study is most efficient, most important from your point of view. So that's why you have to go through or you have to read the standard books to enrich your knowledge, to enrich your idea. So meticulously you have to do your job. Okay, and you have to up to date your you have to up to date your subjects note. Okay, so day-to-day subject notes you have to up to date. Okay, so today I think I am covered up to strain gauge. Okay, so in my next class I think I can start with that details discussions of the strain gauge. Means you can go for the stress, means what do you mean by the stress and strain. Okay, so the deformations of that the stress and strain means deformations. You are giving the force over the area, unit area. Okay, so Young's law. Okay, I know that is plus 2 level idea. Okay, so I think you are able to go through that portion, so I can start with the strain gauge in my next class. Okay, so I hope you are understand till now. I have discussed. If you have any query, you can ask me, so I can rediscuss that point. Okay, so if you have any query, you can ask me. Okay, so I hope you don't have any query about it. So if you have any query, you can ask me in my next class. I don't have any problem. So again, I can rediscuss some of the points if you have any doubts. Okay, so today I am complete my session at that points. Okay, so in my next class I started with strain gauge. Okay, means Monday class.